quickly. All right, 8.4. So let's do little bits of 1, 2, and 4. I'll get you started, okay? So 1a says solve, give exact answers. So exact answers are not rounded off decimals. That's what that means, okay? So that means if you have an answer that's log 4, then you just leave it as log 4. Don't write it as a decimal or such. So let's see, 1a. So I want to solve for x. It's tied up with the log there. So what I'm going to do is I'm going to get this 12 over to the other side. So that's going to be minus 12 from both sides. So that's going to be 3 equals log x, right? So now that I have this log equation, I'm going to, I know this is a base of 10. So this is 10 to the power of 3 equals x. So there you go, that's your answer. 10 cubed is fine, that's 1,000. That should be your answer. All right, B. Now I have log just on one side, so I'm going to turn this into an exponential to get rid of the log. So the base is 5 to the power of, what's on the other side? That's 5 to the power of 2 equals 2x minus 3. That's 25 over here. I'm going to add 3 to both sides. And then I'm going to divide by 2. So 28 divided by 2 equals x. X is 14. You do want to check your answers to make sure that they're reasonable, that the roots, these answers aren't extraneous. And what you got to do there is look to make sure that the argument of the log, that is this input here, make sure it doesn't become negative when you put your x value in. That's not allowed. Okay, so that's 28 minus 3 is 25. So I think we did this one in our example. Okay, I'm going to skip down to number 2 here now, so you can do the rest of number 1. So 2a, all right, solve for x, give your answers to 2 decimal places. Okay, so we can do decimals here. So this is interesting. A, I have a 4 here times 7 to the power of x. So usually when you take a logarithm, you kind of want just the exponent or just the power by itself. So what we're going to do is we're going to divide by 4 first. I'm going to get rid of this 4. So 92 divided by 4, what's that? 23. So 7 to the power of x equals 23. Now I understand that in order to get the x out of the exponent position, that's where I now take the log of both sides, because that one special property of logarithms is that the exponent of the argument, power, can come down in front. So x log 7 equals log 23. Or x equals log 23 divided by log 7. Excuse me. And you can just do this on your calculator. It asks for 2 decimal places, so let's do that. Uh-oh. So about 1.61 here. Okay. Yeah, this x over 3 as a power, that whole power can come down once you take the log. This x plus 1 as a power, take the log of both sides, the x plus 1 can come down. 2x plus 1, when you take the log of both sides, the 2x plus 1 can come down. So I'll do d with you maybe, to show you how that works. So it's 2d here. So I'm going to take the log of both sides. Mm, 2x plus 1 is now a coefficient. I can now divide by log 4 both sides, because that's just a number. Remember, this is just a number. This is just a number. So we just have a number divided by a number. So log 54, close the bracket, divided by log 4, 2.8774. Keep as many decimal places as you can. Oops. 2x plus 1 equals this 2.877. Subtract 1, divided by 2. .877 minus 1. So is that 9.9387? 0.94. Okay, somebody check that, please. All right, so the last one I'll do here, just to get you going. Number 4, determine whether the possible roots that are listed are extraneous to the log equations. So the extraneous roots, again, what we're looking for, the extraneous roots are the x values that are not allowed or that make the equation undefined. What you're looking for is values that make the argument part of the log negative. So the argument, remember, is like the input of the log, or the subject, I sometimes call it, the subject of the log. So if these roots make any of these circled things negative, then you've got a problem. So right now, if I plug 0 in, I get log of 0. That's okay. Well, is it okay? Actually, it's not okay. Negative or 0, I should say, because logs can't be 0. They have a vertical asymptote at 0. So negative or 0. Let's add that. Or 0. Usually, it's the negative that is the common one. So that's already a problem there. And it's really a problem here. 0 minus 1 is negative 1, so that's bad. And then 4 times 0, that's 0 again. That's no good. So 0 is extraneous. 5 is okay, though. Log of 5, base 7 is fine. Log of 4, base 7 is fine. Log of 20, base 7 is good. So 0 is extraneous. X equals 5 is good. All right, so that's kind of how you handle that. If it makes the argument of the log negative or 0, it's no good. All right? Okay.
That was easy.
Right?
So?
No?
I think it's
easy.
I'm telling you.